Hi, everybody. I'm here with Karthik Ranganathan from Yugabyte. Thank you, Karthik, for being here. You're the founder CTO of Yugabyte, so that's an exciting role for you, isn't it?
Yes, it is, Matt. Thank you for having me. Yeah, it's been fun, at least. By way of quick background, I've been in R&D for most of the time, and yeah, having the blast of my life.
Yeah, I looked at your background, and you go way back. So you've been at Microsoft, you've been at Facebook, you've been at Nutanix, you've been a couple other places here and there. I know, I mentioned to you earlier. I saw at Microsoft you were part of the Windows Vista team, which that's a whole exciting thing. So, and you did the wireless features. So, any wireless Wi-Fi problems, we can call you, right? On if someone's still using Vista somewhere.
Well, you'd hope so, but I'd first ask them to upgrade and then tell them to go to somebody else. But no, I think that.
That's okay. So going from Microsoft to Facebook, that's got to be a pretty big jump. That's a big change, drastic, wasn't it?
It was actually. It was. I think primarily because I've been in infrastructure throughout. So and I was in infrastructure in Facebook. So at Facebook I ended up building my first project ended up getting open sourced and becoming what we now know as Apache Cassandra. So started building a distributed NoSQL database, and they were neither distributed nor no. Not no real distributed open source databases back then. This is 2007. But the primary difference was, I guess, this cloud native world and the world of exploding data. Like the world of networking is distributed, but in a slightly different sense, right? Like in the sense you're still thinking about high performance and how you get stuff across the wire and delivered with guarantees and so on. But the world of distributed data, there's a notion of persistence to it. It needs to always work. It needs to heal itself. It needs to just be easy to operate and so on, right? So it's just a slightly different world, but it's been a very exciting journey, like right from the start to my entire stay at Facebook.
Well, so when you were at Facebook, so Cassandra has exploded, right? So did you even think that it could get as big as it did?
Oh my
Or
God,
was this like, no, not
no!
even
I'll
close?
give you an interesting tidbit actually. At Facebook, there were three of us working on this database. We just called it Pure Storage because we didn't want to be very inventive about naming it, and it was just an inside project. And the origins of the project was there was Facebook messaging. Like this is pre-messenger, the messenger that we know now. Is just like
Hmm.
think of it as almost email, right? Like it's kind of sending messages back and forth between people on Facebook, the site, and there was no way to search. And a lot of people were saying, "Hey, could we search our messages? If only we could." Right? And we didn't want to put the search index into our RDBMS. We were using a sharded MySQL back then, and it would get operationally complex, and the data set sizes would be huge because every message that everyone sends to everyone else would have to be reverse indexed. So we said, you know what, let's build this database that works on commodity hardware, and we had a few decisions to make, and we said availability was more important than consistency when the CAP theorem was taken into account. And that's because, messages, it's fine. Not too many people search messages, right? Like, and not too many people.
Yeah.
And if you're missing some messages, you could always complain. We'd go back to the message store and re-index it, right? So we ended up building this database called Peer Storage, and the job of naming the database fell on me because no one else could be bothered enough, right? So I said, sure, why not? Let me name this thing, right? And I thought, any database anybody's building has got to be named after an Oracle theme because Oracle's like the king of databases. So we said okay, what's the stuff around Oracle we can name it after? And Delphi was already taken. There's already Delphix, so that was out. And so in doing a not so extensive research, the next famous Oracle that anybody had heard of was Cassandra. It turned out no one listened to what she said, but hey, what the hell? It makes still a good story. So we said, let's name it Cassandra. So we named it Cassandra, and then we said let's open source it, and it just took off. And we're like, oh man, we should have named it a little better, but too late now. So,
One of those regrets. If you could ever go back, name it something different, right? Well, so there was a time though when Cassandra was out there and it was not as polished. It took a little while. There was a few years that I remember. I remember when it was open source. So I was at MySQL or maybe just at Percona. And I remember when it was open source, it was like, ooh, what's this? This is interesting.
yeah.
And then it really took a few years, and then you started to see like some of the places like DataStax start to form around, can we do a commercial offering? You also started to see, from what I've heard, and I've talked to some Facebook engineers, that there was some divergent because what you were running internally was very different than what ended up externally as we know Cassandra now. And so I know that there's been some of that. So it kind of took a life of its own, and went off and kind of moved into different directions. And so other than the name, any big regrets that you wish you would have done now, looking back, knowing what you know, like, if I only did this one thing, it would have been so much better?
I think it's well, there are many things we could have done differently, but honestly, even the name included, I think the need of the hour is all you know, right? Like back then. So no regrets as far as what we ended up doing with respect to the database. Obviously, nobody could have predicted the rise of the database and the level of popularity it would get, and the number of projects it would power. Just like no telling that in the beginning, right? But it was built for a specific set of purposes, like easy to use, easy to deploy, easy to run, and highly available. And to this day, it does its job really well when it comes to those things, right? But if you think, and the regrets are, I guess there's no regret as such, but if you think about it, many years later, at that time, we couldn't deal with data more than a single node, right? Not really in any way other than sharding your application, which is like a huge undertaking. So it was extremely successful in getting people to go from, I can only deal with data in one node and I really have a world of complexity, to there are ways to deal with data and reasonable performance across multiple nodes, even if you have to give up a lot of access patterns, right? So it was very successful in doing that one thing. I think that was the aim of NoSQL, because back then there was a distinct big data aspect to data where it wasn't really transactions, it wasn't really user facing always, and so I'd say the entire crop of databases that grew at that time, the NoSQL databases as we know them now, like Cassandra, and I subsequently worked on HBase. I'm an HBase committer as well, and Mongo came up around the same time, and Dynamo shortly after. They were all focused on handling large amounts of data. But they were the building blocks for what would happen in the future, which is people wanting to build transactional apps and dealing with transactional big data, right? Like that comes later. So no regrets. I think it did really well. I mean, some of the things I would change if I could are not write it in Java. I didn't know back then that SSDs would come up and really make GC a problem. Also didn't know back then that the cloud would become a thing and large memory heaps would come up and we'd have to deal with that. I mean, just no way of knowing that. And again, definitely didn't see at that time, didn't think about the transactional big data problem where consistency would be more important. Anyways, these are all good lessons learned, but I think it did its job really well.
Well, so just staying on this theme for just one more second, and then I want to jump over to your HBase, maybe a little RocksDB, then we'll get into what you're working on now. I'm curious. So, you mentioned that, hey, it's doing one thing really well. And as I've seen the growth of MongoDB, as I've seen the growth of Cassandra, as I've seen the growth of Redis, all of these projects start doing some very focused, awesome things. And they plug into environments really well, and they do the purpose thing that they're built for. But we see this trend that now we're evolving and adding more and more to these databases, where it is no longer the purpose driven, it's becoming more general use. What do you think about that? Because there's this philosophy, and there's competing philosophy that you want more features versus, look, we want to keep the bloat as small as possible and very focused on performance and what we're good at. And so I'm curious where you fall on that.
Yeah, I think having seen the spectrum of both sides, I think I now feel like the direction the world will go is to get a somewhat integrated database for a majority of the workloads, and for very specialized workloads, it'll start getting specialized in terms of databases. Having to build a general purpose application with very specialized workloads is extremely hard on the application developer side. So I think the bottom line comes to, who are you asking the question? Are you asking the builder of a database, or are you asking the builder of an application or service, right? And you get two very different answers. Back then, right, back when we built NoSQL, the question was really a database builder's point of view, right? Hey, somebody needs to store a lot of data. It doesn't fit in a single node. What do you do, right? And the database builders and the folks in the infrastructure team used to work really closely with the application folks at Facebook and trying to help them figure out how to shard data, how to store it, and it was really a lot of pain, because the app team and the infrastructure team would have to work as one unit to make sure the data was distributed, replicated, highly available, and all of those things, right? So Facebook being Facebook and having very large workloads, right? The footprint is just huge, billions of operations, petabytes or terabytes of data. Everything is huge, right? So the specialization made sense, because if you could do a narrow thing really well, you would save a lot of pain and you'd get a lot of return on your investment. Right? So databases like Cassandra and HBase and all of these grew from that need, right? Like in order to make a simple workload that's very specific but happening all over the place at huge scale become very efficient. That was the first stage of growth. Now, once this made its way into the enterprises and the developers at large and everybody trying to build applications on it, it quickly brought about, okay, I know how to handle the scale aspect. I know how to handle the queries and the transactional aspect, but why am I having two things to deal with, right? And that kind of builds up over time and pretty soon you see even the transactional side is growing and you need scale on the other side. And so you're like, wait a minute, if I need scale on my transactional side and I need scale on my scale side, then I should just have one database that does transactions and scale while not giving up the scale portion. And so now you see databases getting more complex and getting and handling more things, right? But the same architecture doesn't hold. The architecture that we built for scale only but watered down transactions was very different. It fundamentally has to be very different. And the complexity increases when building the database, but the value increases when using the database. I think that's the 2 points of view.
Okay. Yeah, and I mean, right now it's interesting because we've talked with a lot of open source or companies that use open source, and it's very unusual to find one that has just one database, right? They've got like 10, 12, 13 different, like they'll have Cassandra, MySQL, Postgres, all these different, RDBMSs, NoSQL systems, all sitting side by side, all kind of there. And it does create a bit of a logistical nightmare for some of their operations folks. So there is always this, do you add the more features? Do you not? Do you use the databases that you're comfortable with? And then you have the whole people factor as well, because as you bring in new engineers, as you bring in new infrastructure operations folks, sometimes they're like, oh, I hate that database. I'm going to move everything to this other one. And you see that especially on the executive level as well, where a new exec team comes in and all of a sudden you go from we're going to do everything on Kubernetes to everything in the cloud, or we were in the cloud, now we're going to do everything on Kubernetes. And you get this waffle effect quite a bit. It's an interesting market space that we're in right now.
That's true.
And so speaking of other databases, so at Facebook you also worked on the HBase project. Now I know Yugabyte has RocksDB in the core. Were you also working on Rocks?
Rocks, we were working closely with the team building Rocks. So the origin of Rocks is actually quite interesting. We tried to put HBase, we tried to experiment with running, so Facebook has user data, which was on this sharded MySQL tier, right? And and one of the things we noticed was, and MySQL used InnoDB as the storage engine. And and InnoDB is based on a B-tree-based storage architecture. So, like, as in, you want to minimize the number of seeks on disk because traditional disks couldn't offer too many random seeks. So, a B-tree-based architecture really makes that a lot better. And most of the existing RDBMSs, the traditional RDBMSs, are built around B-trees. So, like Postgres and MySQL and so on. Right now, with SSDs coming up new, what really happened was SSD internally can give you a lot of random IOs because the how you translate your random IOs to sequential IOs is done by the SSD layer, right? In firmware, it's done below the line of what you see in software. So that means you no longer needed to adhere to restricting the number of IOPS or minimizing for it. You needed to now go with how many parallel IOPS can you do and how sequentially can you lay out data so that you can utilize the device better, right? So that meant that a log-structured storage model is far more conducive to an SSD than a B-tree-based storage model, right? Like, I'm going all the way down to the guts of storage.
And that's okay because we love that too, right?
Okay, right. So, but popping up a level, right? What does this mean? This meant that the memory to disk ratio of what you needed in order to serve your workload, you needed a lot more memory for every gigabyte or terabyte of storage, right? So like you could do maybe 1:4, 1:5, or maybe even 1:10 if you push it, but you couldn't do much better than that, which means for every 10 units of storage, you need one or more units of memory, right? Like and RAM, and that made the machine builds very expensive, right? Whereas with HBase, what we noticed was going with the log-structured storage format, we could do 1:500, 1:100, 1:1000, depending on the workload, right? So that clearly made a case for log-structured storage, LSM storage being the way to store. Now, obviously, we just tried running HBase on the SSD tier, and HBase was also written in Java, so you can add that to the list of regrets. But anyways, but we didn't know back then. Again, I think Java can be tuned reasonably well to run on hard disks, but it's very difficult to tune this to run well on flash devices, SSD devices, which are much faster. So you start hitting your garbage collection problem a lot quicker, and you have larger memory heaps, which gets harder to deal with. So the upshot is we found that we couldn't run HBase as it is inside that tier. So we needed a storage engine underneath MySQL that would behave like LSN, right? So what we knew all the lessons we learned from HBase. It was in Java. You couldn't just pluck out the code. And MySQL was in C, so you needed something that works with C++ as a storage engine to replace InnoDB and work the way HBase did with the rest of the replication and architecture already in place, because there was a huge operations team already, an expert at running MySQL at scale. Right? So that kicked off the HBase, the RocksDB project, where it was like LevelDB was taken as a starting point, and then we added a whole bunch of concepts from HBase and built that storage engine. So we were connected to the work. We didn't work on it directly, but anyways, that RocksDB was then converted into a storage engine for MySQL called MyRocks, which powers which really made it very efficient to run MySQL on SSD devices, right? So
right, and we actually use MyRocks in Percona server. So
there you go. Yes. Yeah, there you go. So that's the origin of RocksDB. Now coming full circle, we knew we hadn't. It wasn't one, but we had two databases in the open source, Cassandra and HBase, both written in Java, both of which we knew intimately, and both of which we could have used a lot of building blocks and code from in order to build Yugabyte. Right, when we started to build our database, and we knew exactly we wanted to make it transactional. There were significant differences, but there were also large areas that would be similar. However, we said, you know what, for the better or for the worse, we're going to stick to C++. We don't want to go the Java path. Large memory here to stay. High performance is important. So, however,
absolutely.
The other side is let's do it in C++. So that meant the RocksDB building block would be critical for us. And so we started with that.
Okay, great. Yeah, and I remember those times because I grew up as a DBA in the pre-SSD and went through the SSD changes, and it was almost overnight that you started to see these pop up. And right. Actually, in my closet, I have one of the first SSDs that was produced. I think it was 16 gigs, and it cost $2,000. I got MySQL to pay for it at the time because they were like, oh, I want to test this, so benchmark, woohoo! Wow. But it's so interesting because sometimes you go back and you regret design decisions. You've mentioned Java a couple times. My favorite thing in InnoDB when you go into the core was back in the early days of InnoDB in the 4150 series. Obviously nothing was optimized for SSD back then because it didn't exist. And Hecky, who created InnoDB, actually wrote this comment. It's my all-time favorite. I like to bring it up as much as I can because it's just funny. He actually put a cap on storage IOs, and he put, I'm capping IOs at 100 IOs per second because that's all modern disk can do. And he wrote it in 95, right?
He's right. Anything else is expensive, so or wasn't.
Yeah, and that's the thing. When you start, you start with single core machines, and then you get multi-core, and then you get hyper-threading, and then you the advances continually make you jump and allow you to do new things that you didn't plan for before.
Yeah.
And I think that's one of those really interesting movements in the market is, the fact that storage is so cheap now, and even fast storage is so cheap.
Yep.
It has really brought down the requirements that you need for those beefy boxes that you mentioned, because it used to be get as much RAM as possible.
Yep.
Load it up, and you want all your hot data in memory. It doesn't matter what. And
you look at just do it. Yeah.
Well, but you look at the architectures of some of the NoSQL systems, some of the classic ones, they still are not 100% optimized for SSD. And, the more that you use memory...
They're not. In fact, we built Cassandra and HBase pre-SSD era. So, and MongoDB, none of them are optimized for SSDs, as in they will adapt to use SSDs, but they're not built for SSDs, right? So I can talk about the exact things in these databases that would... anyways, just a detail, but
Well, no, but it's super interesting because, you think with all this modern hardware, you think with all these modern advances that that the adjustments and the changes, but a lot of it ends up being architectural decisions that were made back in the very, very early days.
Absolutely. Absolutely. Yeah.
You know, and not all of them are fixable easily, like like Hecky's 100 IOs hard coded where you could just make it a variable or something, right?
Yeah.
Most of them aren't that easy.
No, they're
and
very
I think
fundamental. They're very fundamental. Yeah.
and that's where I think that it's really great to harness the power of the community for a lot of this work, because I can tell you, for instance, MySQL, during that 4.1 to 5.1 time frame in that range, when they were still an independent company, they really had a hands-off approach to InnoDB because InnoDB was owned by Oracle. And so it was the community that brought things up. Now, you mentioned RocksDB, for instance. Mark Callahan was at Google at the time, and he was, let me go ahead and let's fix those things that are broken in InnoDB. And Peter and Vadim over at Percona, where I am, they were like, oh, let's fix those things.
Yep.
And there was a lot of community-led effort to fix and overcome the bottlenecks.
Yep, that's right.
And that's why, it's super important. Now for you, was the decision to open source Cassandra or easy? Was it just like, this is what we're going to do? Like, was it, or was that because coming from Microsoft at the time, Microsoft was like, oh my God, open source, right? Back in the early to mid 2000s when Steve Ballmer was there, he famously said Linux is a cancer. So open source really wasn't in the Microsoft lexicon, but going to Facebook, it was a lot different. So did that strike you as odd, or?
No, it was, I think maybe it had to do a little more with my own personality, or maybe it had to do with the fact that I hadn't been fully indoctrinated in the Microsoft ways. Like, I was still an engineer at heart more than anything. And there was a number of us back then that, it was like, okay, fine, that's what the company wants to do, but that's not necessarily how we think about things. So it wasn't too hard, actually. Like, and at Facebook, I think even at the time, I'm not sure about now, it's been a few years, but back then at least, there was a distinct thought process towards open sourcing. The reason we didn't open source more is because it was more work open sourcing it sometimes, because it's so integrated with the Facebook pieces of technology. And with Cassandra having been built without that level of, there was still some integration. We use Facebook's version of Thrift and a whole bunch of stuff, but at least it was small enough to where we could open source the dependencies with it. And the community over time, obviously, no piece of infrastructure can be static, right? It has to evolve with changing libraries, changing hardware, changing everything, right? So it's great that the community formed around it and kept pushing the limit. And so it is what it is today because of a lot of people. But it was easy for us to do so, and there was a good amount of encouragement to do so. And I didn't know what to expect. To be honest, I really didn't expect what happened afterward, which is which is awesome, I think, and I mean that in a very positive way. But it was still exciting to see some interest from outside and some people talk about it and have a bigger group to work with on that. So that's really been a good journey. It's been very fruitful.
So you left Facebook, you went to Nutanix for a couple of years, and then you got an itch to on creating a new database, a new company. What inspired you then to say, okay, I'm going to jump in and I'm going to create a new open source database, something that ended up as Yugabyte? What was that kind of problem? What did you see? What was the light bulb moment?
Yeah. So, okay, so maybe I'll give you a little bit of the inside story that may not be externally known. But anyways, so myself and my co-founder...
I love inside stories. Okay, it'll just be between us.
Okay, great. It's between us, but we'll just do it on the podcast anyway. So, Nutanix, Dheeraj, who's one of the founders and the CEO for a long time at Nutanix, he and a couple of others from Lightspeed, they reached out to Kannan, my co-founder at Yugabyte. Mm-hmm. And Kannan and I were working together on HBase and the next generation of HBase. We were going to build a database that we codenamed it HydraBase internally, but we were going to build this for what looks closer to a modern cloud architecture, right? And in C++. We were starting this work there. And the longer term ambition that the two of us had was to start a company around making databases easier, because we felt that the database world had diverged even back then. This is back in 2013 when we both joined Nutanix together. We had the ambition, our thought process back then was, the world actually needed a new database because there were enough things that were different. Like we talked about SSDs, we talked about cloud. There's a whole another thing where you have these back then in Facebook, inside Facebook, it used to be nearby and far away data centers, which are what are called zones and regions today in cloud. Like the terms weren't like as well known back then. But anyways, how do you architect a database for this type of architecture where replication is built in and you can actually offer high availability and go after consistency? So these were some of the things we were starting to see as patterns. There was also a number of operational things that you could make easy. There's also a whole journey that you have to keep building along on the database side in order to handle more data and more IOPS at scale. So a number of these things had come into our work that we were doing with, firstly Cassandra and then HBase and this next database we were building. And we wanted to bring that to the enterprise at large because at Facebook, it would always be specialized access patterns, and rightfully so, because that was the need of the hour. But those type of access patterns are going to be the same friction that you see between like using an Apache Cassandra and what the enterprises truly want. There is some area where it's very powerful, but there's some areas where it's deficient, right? And you constantly see people struggle with this on what kind of databases can I use to make the data layer a whole, right? Like that's really what they're trying to do. So we wanted to go do that, but Dheeraj made a very compelling point. He was like, hey, it's still in the distributed storage area, even if it's not databases, and you guys know technology, but learn building a company, learn about enterprise companies, and from a product company, and yeah, it seemed like the right thing to do. We said, hey, we'd probably stay for a year or two. We ended up staying 3 years. It was a blast. We actually had a lot of fun. But the calling was always to go back and build a database. That was the long-term plan anyways. So then like in 2016, we said, like, you know what, we're going to go talk to people and go after, chase this dream of ours, long-time dream of ours. So
right.
So we said, okay, let's go talk. And when we talked, it was actually an interesting landscape back then. The tech companies and the forward thinkers were all thinking, how do they move to the cloud? And there's a small fraction of them. And they were thinking only a small fraction of their workloads because anything else was too much work. And no one wants to think about inventing work for themselves, right? And the enterprises were like analytics, like Snowflake was just starting to get some traction. So, and this is 2016, right? Yeah, and analytics was clear, it was headed to the cloud, and enterprises were okay with that. But system of record and critical data and OLTP systems were not, right? And most of the people told us, like when we talk to enterprises, they're thinking about it. It's not in their roadmap to move to the cloud, right? And the journey it's been interesting to see because based on our experience inside Facebook, it felt like the breadcrumb was leading to a place where the data tier has to become cloud native. We had seen Kubernetes come up, we'd seen microservices come up, we'd seen zones and regions and public cloud architectures come up, and every one of those things had happened inside Facebook a few years before. So it felt like that was the time when in a few years the data tier would pick up. So we said, this is the time, let's build it. Let's build it the way we would have built it at Facebook without all of these hindsight 2020 kind of learnings, but also build it in a way where the enterprise and people at large can use. Because like having built Cassandra and HBase, a number of people came out and reached out and said, hey, can you add that secondary index? Or can you give me a simple transaction? It's like, yeah, but how about it doesn't work all the time? Does that work for you? And like,
yeah. So that's not good to have eventual or inconsistency.
Yeah, the design point was just different, right? Like, and adding something like this in would just be too much of a lift. It's just like fundamentally changes the system at its core. So,
yeah. Well, you guys have built something that's a little unique because you have stayed true to the Apache 2 license. We've seen that a lot of other companies have already started to shift. They've started to, we're going to do, whether it's SSPL, a lot of people want AGPL.
Yeah.
But you have stuck with Apache 2. Now, what was that? You chose that, 4 or 5 years ago now. Is that something that you felt pressure to change?
No, actually, it's been, there's theory and there's practice. There's always some level of worry about if you got the theory wrong, but when you see it work out in practice, it just makes it a lot easier, right? So the decision, by the way, was not light. It was actually, there was a lot of thought that went in. So in 2016, when we started the company, we said we didn't know if we wanted to do open source or not, because there was a lot of confusion and we are proponents of open source, having built multiple open source databases and worked in the
Right.
community and, committers and so on. But there was a lot of cautions from, the business side, like, VCs and a whole bunch of people about really evaluate if open source is a viable business model. And 2016 was a bad year for that. Like, as in, it was unclear. Like, none of the open source companies had really broken out yet. And so we said, like, you know what, this is a one-way street. You open source, you can't undo it, right? Like, you're just, like, there's no, going back on it is almost like a breach of trust. So, and we wanted to start the company. So that put us in the only possible spot, which is, let's keep working on the product and be ready to open source it. Like, let's behave as if we're open source, but not actually open source it. Let's evaluate. Let's understand the market, right? So I think if you take out the first 6 months and just like setting things up and getting things ready, it took about a year for us to get our bearings on what we wanted to do and how we wanted to go about it. And we said, like, we're going to go the one thing was clear in talking to our customers early, which is that people wanted the transparency of an open source database, specifically in the OLTP segment. And databases like Oracle are amazing, but people don't really know how it works or what it does or what they pay for or what the alternative is, or a lot of those type of issues, right? So we said we are going to go open source, but the fear that Amazon would take it and run it, that existed right back then. So we said we're going to keep about 80% of our core database features in the open. 20% are going to be enterprise features. They are things that only advanced enterprises would need, and the other big piece of the business we had to think about was also that, hey, what if Amazon builds the remaining 20% and runs it and puts us out of business as we get traction, or Amazon, anybody else? I'm just using it as I'm just picking on Amazon, but anybody could do that. Our realization was, and at least the theory was, that people pay not for the database features, they pay for the ability to consume them, right? This is what Red Hat had shown us. It's not the features in the operating system. It's about making it enterprise grade, and they built a really successful business out of this. So our theory in 2016 was, we need to not just think about the database, we need to think about the consumption of the database, right? And it wasn't a big secret that the world would eventually head to DBaaS, but it wasn't clear when. So we said, you know what, we're going to strike the balance between the two sides and build something completely radical and unique. We're going to build a software-defined DBaaS, so one that we can run when the time comes, but one the enterprises can run themselves, and that sits outside the database. So we'll make the database mostly free or open source. A small percentage of the database features would be held closed. This is primarily to prevent the Amazon threat, and build a complete product on the side, which is a software-defined DBaaS. So you could just get turnkey, deploy, and compete with Amazon's managed services like Aurora if you wanted to, right? So that was really the vision that we started executing on. And we launched the company in the end of 2017, and we said for our license, we're not picking AGPL because, hey, Mongo was AGPL, and it still didn't stop Amazon and Azure from having a competing Mongo service. And Elastic was something, they changed their license. So changing licenses doesn't really stop people from competing, right? So one way or the other, it's gonna happen, right? So we're better off offering what customers want. The problem why customers adopt Amazon is because I want a service that's easy to consume, but the maker of the software doesn't have it. Where do I go? I go get it wherever I can, and Amazon's offering it, I'll take it from them, right? So it's more the dramatic growth of the cloud where everybody missed the boat on building a managed service on it, and Amazon was simply trying to make their own cloud more compelling, because what's the use of a cloud without any services? So they said, okay, let's put the useful services, and that became a really big business, and everybody else missed out, and now it feels like it's strip mining open source and whatever, right? So we said, hey, let's do the simple thing. Let's have stuff in the cloud that can compete with the cloud vendors, and additionally, you can take this on-prem or go to any cloud or run it yourself, right? So with that kind of a value proposition, why would somebody go to Amazon specifically if they're able to get everything from the makers of the database? So we felt like that's a good enough, well thought out reason. And let's go with that theory. So, and a year later, we saw that most of the people were stickier to our platform product, which is the software-defined DBaaS, more so than the database. And we said, you know what, this is the last stop. We're just going to remove it. We're going to make Yugabyte as open source as Postgres, because we were also hearing from the Postgres community, hey, if you're supporting Postgres, how come you're not as open source as Postgres? It's just like, you got to be as extensible and open. And we said, yeah, it was never the intention. It was done just to make sure that there was business viability, and this is not even affecting it. So why not just make it completely open? And that has really led to a dramatic inflection in adoption of Yugabyte, and even the commercial results have been great as a result of that.
And you mentioned the Postgres, and that's a compatibility that you're not building anything on Postgres itself. It's just compatible because it's using the same SQL language and the same
No, we're more than
interfaces,
that. No,
correct?
no, we're more than that. We
Okay.
follow. So I think Yugabyte is a combination of the upper half of Aurora and the lower half of Google Spanner, so to speak. I'll explain why.
Okay.
So we reuse the Postgres code, so feature for feature, bug for the upper portion of the database. So the query engine is actually Postgres code vanilla. So when the application hits, the database, it's actually talking to the Postgres code, which receives it, which checks for, the correctness, and then does a query plan and the execution plan. The query and execution plan is where we inserted our code and started building stuff to make it work well on a distributed substrate. And the storage engine is completely changed, right? So if you
And that's built on MyRocks, or not MyRocks,
it
RocksDB.
uses RocksDB, but it also uses a lot of other
Okay.
things. Like even the RocksDB is heavily modified because RocksDB is a single node database, and if you want to do consistency across nodes, you need
Okay.
Raft and other things. And so we pulled out the write-ahead log and the MVCC, and so we use RocksDB as the storage component on a node. So each node storage component is RocksDB, which is also modified to make it very optimal for the access patterns from above. The replication and transactions manager and distribute that. So the replication is built using Raft and a transaction manager that's like built on top of this Raft system that enforces consistency. And the upper half is actually just Postgres code, right? It's actually an extensible API layer. So we have SQL and NoSQL to not fight the war, but embrace it and let people come from either direction. But nevertheless, the SQL part of it is actually vanilla Postgres. Not vanilla Postgres.
Oh, cool.
Postgres, it was vanilla Postgres on top. So that means we support, stored procedures, triggers, extensions, partial indexes, what have you of Postgres.
Okay. And so that makes it very easy to port over then.
That's right. So the porting over, we kind of give the mental map of no application or most applications built for a single node will not work well in a distributed substrate. That's just like laws of physics, right? So you have to think about a few things, but you have two options here. You can rebuild your application inside out, or in Yugabyte's case, you can get your application to run suboptimally on a distributed system. That's step one. And then go look at what are the slow queries and what are the adjustments and tweaks you have to make, which is not a whole lot, and get it to work well on a distributed system. Like as an example, you may be using an auto-incrementing ID, like it's called the serial data type in Postgres, right? Like where you insert a row, it'll give you the ID is 1. You insert another row, it'll give you 2, right? It just works as is on Yugabyte, except for every ID that's issued, by default, Postgres would go somewhere and fetch another ID. So that means every insert is now incurring an extra RPC, which means your insert performance is really going to suck, right? So the only change you need to do is Postgres actually allows you to modify the session or the table to assign these numbers in batches, like these auto-increment IDs in batches to all of the nodes. So just say, hey, alter it, set the cache size to like 25 or 100, and now you're suddenly making only one call for every 100 calls for every node, and suddenly your application performance goes up. So that transformation is a lot easier. Whereas if you go to any of the other distributed SQL databases, the way is, hey, you should use your UIDs, and that's like now you're just left reasoning about a lot more complexity.
Oh yeah, I mean, that's great that you're looking at that level, especially as things move over, because one of the issues for a lot of people now is, unfortunately, people want the easy button. They want it to be very easy to get started, and that's pushed a lot of what had classically been more database engineering skills, DBA skills, down to the developers, who are just give me a table, give me the ability to
bother me with
query.
so much information. I just need to write an app.
Yeah. And I think that's where it's super interesting to see that kind of movement in the market, because we're seeing more common issues come up over and over again that are like, oh, well, everybody knew this 5 years ago, but now it's a new set of developers who are just used to going to Amazon or Microsoft or Google, clicking a button and there's a database there, and then when it's slow, they just go swipe. Oh, now we're going to go to the next instance size, right?
Right.
And it's a super interesting thing, because as we talk about trying to get down to the nitty gritty, there are so many inefficiencies that we've built into different database layers over the years, but also our applications. It's a good reminder that as you do porting, as you move things, not everything's always going to just move over without changes. And I think that's, when we're used to easy, we want easy.
That's right.
And it's not always that case.
That's
so,
right. Yeah, I think the trade-off here, at least that we're trying to strike, is that it's not, we don't try to be 100% on either side. So we try to give easy until it gets expensive or complex or inefficient, and at which point you can start thinking. That's really the approach, right? So it's easy enough to move, but if some things don't work well, then we try to make it easy enough for you to find out why it doesn't work well.
Yeah. So Karthik, let me finish with this question. What have you guys got going on? What's on your roadmap? What are you really excited about here? What are you seeing that's coming down the pipeline that you're like, whoa, this is exciting. I can't wait for this to be out there.
Yeah, I think
curious.
Yeah, no, totally. I think great question. I think a lot of stuff coming that's interesting, right? Like the first thing is actually beefing up the set of core database features. Like, as you know, Postgres is incredibly feature rich, and we're still catching up on some of these features. And some of the things coming out from our side is the ability, for example, to support GIN indexes or generalized inverted indexes on documents, and text search, and gist indexes, and post-gist geospatial. So there's a whole bunch of stuff on that side that's going to make it super interesting. We also support Postgres extensions, which are like super interesting.
Oh, that's really good.
Yeah, and that's like amazing. At least the query layer extensions, and so and Postgres itself is an extension, right? So there's support for more extensions that we've planned, including ability to read from foreign tables, which are super interesting. So that's just on the core database side. The other interesting things we're keeping a close eye on, like it's super exciting that Amazon's building this SQL Server interface to Postgres. It's called Babelfish. Right? And,
Yep.
And they're building it on vanilla Postgres, and guess what? Yugabyte uses vanilla Postgres as the upper half, so this could be a really interesting thing for us to offer SQL Server as a distributed database API to people. So that would be another really cool thing. That, of course, that's not just the core database. It's more about expanding how things become really easy for people. So that's an interesting thing. There's always the cloud native world where we keep trying to. One of the other things about Yugabyte that's unique is we're the only ones to do both synchronous and asynchronous replication. So we're a distributed database that can asynchronously replicate as well. So we can easily work in both the traditional world where people want async, and the new world where it can be stretched across regions. So we are beefing up a lot more on the async replication capability. So that's pretty exciting on that front. And finally, the cloud native side, including our own cloud offering, there's a number of enhancements going on to make things better and faster and so on. Finally, I'll say that the path to adding more APIs or adding more functionality in a distributed database, when you have a lot of data, a lot of simple OLTP queries start looking like OLAP, like starting from account start.
Yeah.
A lot of the parallel capabilities and all of that is also going into the database.
Okay, excellent. Well, Karthik, I thank you for sitting down with me today. This was a great chat. I really enjoyed hearing about kind of your journey and some of the things that happened at Facebook and what you've worked on here at Yugabyte. This is great. I'd love to have you back sometime. I see you submitted for Percona Live, so we're going to be looking forward to hearing what you have to say there as well. But it was great chatting with you today, and I hope you have a great rest of the day.
Awesome. Thanks. Thank you. Thanks, Matt. Thank you.
All right. Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.